Okay, it is known that it's impossible to construct a line segment whose length is pi, and it's done by Lindemann around 1882. But there was a kind of long history of trying to construct such line segment, and one of the famous one is around 1685. The method is done this way. Okay? So in this video, I just try to give you a simpler version of the construction here. And at the last construction, the line segment MN, its length is like this much, and that is very close to pi. Okay? So it's kind of get the right number up to the first decimal position. Okay? So for that, let me show you this construction stuff. So all you need is just to sketch that diagram and just show step-by-step constructions, right? So let me just give you that one. In the first, we put two vertices, two points at the 0, 0 and 1, 0. Okay? And using that part as the one side of 12 gun, 12 regular gun, so we just construct it. Of course, to construct it, we need to detect the coordinates of each point. But for this portion, you just simply say construct 12 regular 12 gon, having one side is just line segment AB. Is it not? And from this 12 gon, first we just draw a line segment between L and G and looking for the intersection, right? So find the intersection, name that N, right, with the x-axis. Next one is line segment between I and D and line segment between A and J. And we found the intersection points between those two line segments. Let's name that is M. Then the line segment that MN satisfying that property, right? So it's kind of approximation to pi. So using this one, let's just show, after constructed, why the length of this line segment is exactly like that way. Okay? So let's go to the next example. Now it's asking, find the coordinates of those necessary vertices, right? Out of these 12 of them. And because those vertices are needed to construct all these line segments like that, right? So first, when you started, the point A is 0, 0, point B is 1, 0, and to get the coordinates of C, we need to know how much this line segment is tilted, right? So what is the kind of slope of this line, okay? The BC. To find out that, when you look at the center of this circumscribed circle of this 12 gon, let's say that is O, then we have this isosceles triangle. Right? Then we have 12 gon, means this angle must be 360 divided by 12, right? So it's going to be 30. Then the sum of these two angles must be 150, and they are congruent, so each one must be 75. So that's reasonable. So please explain the whole thing, right? Then same thing happens on this isosceles triangle too, right? All of them. So we are going to get 75 here too. So the sum of these two angles are 150. Then from out of 180, the remaining one must be 30, right? So let me just sketch that way. Let me sketch here for the next one too. So that is 30, and the length of each side of this 12 bone is 1, right? That's how we arrange it. So this side must be 1. Then we know that in any right triangle with 30 degrees one side, the ratio among the sides is 2, 1, square root of 3. So if we change that one to 1, then this side must be 1/2, and the length of the bottom should be square root 3 over 2, right? So that's the actual length in this coordinate for this triangle. So the C, the point C, how much do we need? Starting from 0, 1, and that, which is scale 3 over 2, right? So x coordinates of point C is 1 plus scale 3 over 2. Then because of that, we know the x coordinates of L must be same as this one, right? When you look at it, those points, the vertices are kind of on the horizontal lines, right? The same horizontal line. So whenever you got the x coordinates of these right hand side ones, the left hand side points also has same x coordinates, right? For the corresponding ones like that. So we can figure out that way. Then how about the y coordinates? Starting from 0, we're going up by this much, right? So y coordinates should be 1/2 for point C. Then when you look at this one, this is right angle again, and because that is 30, then this must be also 30, right? There's a kind of a symmetry by this line. So this side is 1, then that should be square 3 over 2, and this side must be 1/2, right? So x coordinates of D is from x coordinates of C plus 1/2, right? So it's 3/2 plus square 3 over 2, and from 1/2 we're adding scale 3 over 2, right? So it's going to be 1/2 plus scale 3 over 2. That's the coordinates of D. Then the E is easy, right? So same x coordinates like this, and y coordinates is just adding one more. So it's going to be 3/2 plus scale 3 over 2, right? Then you can keep doing, right? Same thing. So this portion is 1, and that is scale 3 over 2, and that is 1/2. So the coordinates of f, we have to reduce 1/2 from this one, right? The x coordinates of it. So it's going to be 1 plus scale 3 over 2, and adding scale 3 over 2 again here, right? So two of them. So y coordinates of point f is 3/2 plus just the scale 3 over 2, right? And for g, it's 1, and that is 1/2, right? And this one is scale 3 over 2. So x coordinates of g needs to subtract square root of 3 over 2 from here. So it's 1. And that's reasonable because it's matching with point B, right? The x coordinates b is 1. So with our calculation, actually, we can figure out that. So it's 1 comma. And from this y coordinates, we need to add 1/2, right? So if you're adding 1/2 more, it's going to be 2 plus square root of 3. And it's reasonable because square root of 3 is 1.7 something, so 2 plus 1.7 is 3.7, right? So it's around that. Okay? So please try to find out the coordinates of the others, right? Like this much. Okay? So that's the coordinates of all of them. And at the bottom, you have all these results, right? So you know the results, but please show me how to get those stuff. So don't just give me the answer, right? I know you know the answer, right? But please explain it how you get it, right? Using those triangles. So that should be the answer for this part. Then the next question is find the equation of the line GL. Okay, so passing these two. Okay, so let me just copy that G and L, the coordinates of it. G is that, and L is that, right? So write down. G is 1 comma 2 plus square 3, and L is negative square 3 over 2 1/2. Okay? And these are the answers, right? The solution for the education. So you know the answer, so you have to show me how to get that one. Okay? So the first case, what is the equation for the line GL? Okay, because the coordinates of G is that and L is that. So for any equation for line passing 2 points, we have a formula for that, right? So like x1, y1, and x2, y2. Then the line passing those 2 points is like uh, y minus y1 equals, the slope is y2 minus y1 over x2 minus x1 times x minus x1, right? That's the formula for line equation passing 2 points. So let's just use this one because L is kind of left side of G. So let me use this one for x1, y1, and coordinates for G is for x2 and y2 in this format, right? So y minus y1 is 2 plus square root of 3, right? But let me use, because it's kind of for easier calculation, it's okay to use any points on the line, right? So this is also possible. Okay, so y minus y2 is 1/2, and y2 minus y1. Okay, let me change the name like this one and x2 like that, right? So then this is x2, y2, and x1, y1. Right? So then you can just keep the same way like that. So y2 minus y1 over x2 minus x1, right? Okay, and times x minus x1. It's like that, right? So actually you can assign x1, x2 and y1 and x2, y2 in a different way, right? But doesn't matter. So I just choose a simpler calculation case, right? So let's just arrange them. Simply this is y minus 1/2 and 3/2 plus square root of 3 and 1 plus square root 3 over 2 times x plus square root 3 over 2. So let me multiply this on both sides. So 1 plus square root 3 over 2 times y minus 1/2. Then the right hand side is 3/2 plus square root 3 times x plus square root 3 over 2. Okay? So by distribution, let me just multiply like this. So 1 plus square root 3 over 2 times y minus, when you multiply 1/2 directly for this one, we are going to have 1/2 plus square root 3 over 4, right? Let me do the same thing on the right hand side. Then it's 3 over 2 plus square root 3 times x plus, just multiply this one to here. So let me just write down the result, like 3 square root 3 over 4, right? Plus 3/2. Then let's just arrange them. Okay, but let me keep this one as it is and subtract this on both sides. So on the right hand side we have 3/2 plus square root 3x minus 1 plus square root 3 over 2y, right? Just subtract this one on both sides. And left hand side we just cancel out, right? Minus of this entire one cancel out. Right hand side we have that. And subtract this one on both sides, right? So we cancel out on the right hand side. The left hand side we have is negative 1/2 plus square root 3 over 4 already, and subtracting this one, right? So 3 square root 3 over 4 plus 3/2, right? So the right hand side we have negative 1/2 minus 3 halves together is negative 2, right? And negative square root 3 over 4 minus 3 square root of 4. So total is negative 4 square root 4 square root 3 over 4, right? So canceling 4, we only have square root of 3, right? And the right hand side is same. So let me just rewrite again. The entire equation looks like 3 half plus square root 3 times x minus 1 plus square root 3 over 2 times y equals negative 2 minus square root of 3. So that's the equation for the line passing the G and L. The next question is, then what is the coordinates of these the section points? Clearly, the y-coordinates of that is 0 because it's the point on the x-axis. So all you need is just x-coordinates. So to find that x-coordinates, key point is that point is on this line. So it must satisfy that equation, right? So when you substitute 0 for y, then we will get the x-coordinates of point n, right? Like that. So for part B, just to substitute 0 for y, right? Then we have 3 half plus square root 3x. And because y equals 0, we lost everything, so it only giving us this one. Okay, then let me, because we need to take the division, so let me multiply 2 on both sides before doing that. So x must be negative 4 minus 2 square root 3 over 3 plus 2 square root 3, right? And for kind of simpler version of it, we can kind of rationalize a denominator, right? So we multiply the conjugate of denominator at numerator and denominator together. So the numerator is negative 4 minus 2 square root 3 times 3 minus 2 square root 3. Denominator is simply square of 3 minus square of 2 square root 3. So 4 3 is 12, right? So altogether is negative 12 by distribution rule and plus 8 square root 3 and minus 6 square root 3 plus 12, right? Okay, over negative 3. So we cancel out that and we have 2 square root 3, right? Over 3. Okay, so that's going to be 2 square root 3 over 3 with minus, of course, or it can be negative 2 over square root 3, right? I think that's the simplistic version. So the coordinates of that n is going to be negative 2 square root of 3, comma 0. And we are going to need this one to calculate the measure of that line segment and later. Now, the next case is the equation for this line segment or the line di. Then when you look at the forms, actually these two lines are perpendicular each other, right? Because the line EH and that they are parallel, right? And these are also parallel. And in this case, that is parallel to this one, right? So you can see those lines are perpendicular. Okay? But please explain it, why or how, something like that, right? Because we just rotate 30 degrees and 60 degrees, so you can explain that way. So please do, but let me just skip that part. Then, when you have a line segment, the equation for any line is mx plus b1, then when you get the perpendicular line, then the slope of this line is negative 1 over m. Remember, right? It's a negative of the spherical of previous ones, right? And passing points will be different, right? Like for x, y-axis. So that's the relation. You need to get the negative of the spherical of the previous ones. So when we get the line equation of that, where is it? It was this one, right? So let me just copy that one more time here. So okay, please, we need some space over there, but so that one was like 3 half plus square root of 3 x minus 1 plus square root 3 over 2 y equals negative 2 negative square root 3. That is the equation for this one, right? Right? Like, it was GL, sorry, it's a GL, sorry. Yeah, that one is for line GL. So the slope of this line is going to be negative spherical of slope of this line. So let me just find the slope of this. To see that, let me add this one on both sides. And of course, like that. So arrange them again. So 1 plus square root 3 over 2y equals 3 half plus square root 3x plus 2 plus square root 3. So to get that kind of forms, slope and y coordinates format, let's divide both sides by 1 plus square root of 3 over 2. So 3 half plus square root of 3 over 1 plus square root of 3 over 2. X and whatever, which we don't need it. All we need is just m, right? We found them, then we need to take the reciprocal of it, right? With a negative. So the slope of this new line is negative reciprocal of that, right? Okay, so that line equation must look like y equals this new slope plus some number, right? Okay. So that is whatever. Okay? So all we need is just any points on this line, di, must satisfy this one, which means if we substitute the coordinates of d or coordinates of I into this formula, it must satisfy. And by doing that, we can find out what this y coordinate or the y intersection points will be. So does it say anything? Okay, it doesn't say anything. So yeah, put that's one. So now this is for the example, right? Find out that constant term. Okay? In this format, so careful. So we can arrange that way. So let me let me multiply this denominator, okay, to show that way. So on both sides, then this y equals negative 1 plus 3 over 2x plus, of course, whatever that c is, right? So let's put s, because s is what? We have to multiply this on c, right? So it's going to be like this one. So all together, it's going to be one number, right? So let me just put s in the case. Then adding these terms on both sides, so we have 1 plus square root 3 over 2 times x plus 3 half plus square root of 3 times y equals whatever x, right? And that's what you have over there, right? Okay, anything? I think they are matching, right? Okay, let's make sure got the right ones. Okay, so we found it. Then all we need is just substitute uh, any coordinates of any points, right? D or I, but we already found D, right? And what is it? D was like that, right? 3 over 2, square 3 over 2, right? Oh, no, that is for x-axis. So let me write down. It looks like it only gives the x coordinates, right? So the y coordinates must be 1/2 square 3 over 2, okay? So I'm going to fix that one later, but please, you can calculate, okay? So having that, then all we need is just to substitute those coordinates. So x coordinates of D is 3/2 plus square 3 over 2, okay? Plus the y coordinates of that point D is 1/2 plus this one, and that should be s, right? So please calculate it, okay, and simplify, and finally please make sure we got that constant term for that expression, okay? So now we have the line equation for this line di, okay? So please keep that one. Then now let's just try to find this new line uh, h and j. And in this case, uh, we have a kind of better and simpler kind of explanation about it. When you look at this, do you remember there was a center O, right, of the circumscribed circle for this 12 bone? And when you look at those, it's kind of like this, right? So this is a vertical line, and this is horizontal line for that. And it's exactly kind of symmetric, okay, by this line, right? So which means this one and that one are perpendicular, right? And because these are the symmetric by that, which means it's like 45 degrees, right? You can think that way. Then which means this one also has 45 degrees over there. So please explain that. Let's do this one. So the slope of this line is simply n, the n equals 1, right? Slope is 1. So all we need is just to y-intercept points of this line, right? So we know the line equation must be y equals x plus some constant t, which is the y-intercept points of that. And at this moment, the point H, the vertex of one of the vertices of this 12 gon is actually the y-intercept points of this line, right? So all you need is what is the y coordinates of this H, right? So from the previous one, we know H is certain value, and the coordinates of that, y coordinates of that is 2 plus scale 3, right? So that line equation must be looks like this way. Okay, so the remaining one is we already found the coordinates of n before, right? And all we need is that intersection points, right? So to find the intersection points of two lines is just to solve the system of equation, right? The line equation for that and line equation for that, and looking for the same xy values satisfying both of them, right? So over here, this is how we can arrange, right? In the previous parts, we already found out the line equation for one of them is this one, and we just show the second one looks like this way. Okay, so let's just find out the common points satisfying both. Okay? Then how can you do that? This is typical formats of system of equation, right? Just substitute x plus square root 3 for y in the first place, right? So is 1 plus square root 3 over 2 times x plus 3 half plus square root 3 times y, but instead of y, we substitute x plus square root 3, right? And that should be 9 plus 5 square root 3 over 2, something like that. So we have 1 plus 3x, and by distribution law, we have 3 half plus 3x plus, for constant term is 3 square 3 over 2 plus 3, right? And we have that constant over there. So we need to put this together, which is 2 plus 3 square 3 over 2, right? X equals 9 plus 5 square 3 over 2 minus this, right? So please do, right? A simple calculation. Simplify this one first and multiply divide both sides by that. Okay, and we are going to get x. So it must be like this after simplify, right? Then after we have that x, okay, after some calculation later, we got it. Then substitute this one into here, right? Then we are going to get y equals this one. Okay? So that's the coordinates of M. This one. Then lastly, the length of those line segments, M and N, like that. It's just the distance between those 2 points, right? So if we have x1, y1, and x2, y2, 2 points, and the distance between that is the square root of x2 minus x1 squared plus y2 minus 1 squared by the Pythagorean theorem, right? So all you need is just to calculate it, and when you simplify the inside part of it, we are going to get that. Okay? And it's close to this, right? Maybe you can use your calculator or something like that to find it, but if you got this much, it's enough. Okay, so we just show that our construction really gives us the line segment whose length is very close to pi. So this last part is actually your homework. Okay? So after you show this much, like coordinates of M here, then show this one, okay, to find that entire part at the home. Okay? So that's the end of chapter 22.